Good morning guys. Today we will see in this video how to print Fibonacci series with recursion and without recursion. Okay, let's start with without recursion. This is the Fibonacci series, starts with 0 1 and from then onwards the value will be sum of the previous two numbers. 1 comes from by adding 0 plus 1. Similarly 2 comes from by adding 1 plus 1. 3 will come from by adding 1 plus 2, so on and so forth. So we have to print this number. Okay, so let's ask the user which number in the Fibonacci series he requires. So this will be the first, second, third, fourth, so on and so forth. Okay, so let's write this function. So as I said, like we have initial numbers 0 and 1, these numbers I am talking about, and then let's take one or two more variables, count and then sum. We have to write a loop while count less than number. Okay, we have to do count plus plus, so we have to reach whichever number user requested for. For example, if he wants 9th number, we have to print 55. So this loop is to reach up to 55. So while reaching, as I said, like we have to start with 0 and 1, but then we have to keep adding to get the next consecutive numbers, also parallelly by changing the values of a and b. For example, if we are here, we are calculating this number, a and b, a will become 1 and b will become 2. Similarly, if we are calculating this number, a should become 5 and b should become 8. So let's do this. So sum will be a plus b, right, and then a should become b and b should become sum, right. So finally we have to return the sum. Let's see what is the output of this. I have to declare it number. Yeah, let's ask for first number, so 1, which is right. Let's ask for second, 2 is right. Let's ask for third number is 3, so that is also right. Let's ask for fourth number is 5, so which is also right. Let's ask for fifth number, 8, which is also right. Then sixth number, 13. So this code is working fine. Okay, let's modify this code to print entire series up to, for example, if you ask for 6, so it should print the whole series. So how we will do that? Simple, let's have a loop, call the function on each and every number, like this. Okay, so let's have a space. Yeah, then let's do this. If we enter 9, so it is printing all the numbers. So if we want to print 0 1 as well, just have one printf statement like this, then you are done, like this. Okay, I hope the code is clear. Only thing we have to make sure is we have to start with 0 and 1, and then we have to change the values of a and b. So the b will become a and new sum will become b. For example, let's start with 0 and 1. So this will be a and this will be b, so this will be sum. So to calculate the two, the b should become a and the sum should become b. I hope the code is clear. Still, if you have any doubts to clarify, please leave a comment. I will try to address you. So just now we have seen how to write a Fibonacci series without recursion. Okay, let's see how to do the same with recursion. So with recursion it's pretty simple. So for example, let's call this method as a fab series, fab with recursion. again it will take number n. So we have to write a base condition and then recursive line. So the base condition will be if n equals to 0 or n equals to 1 for these two numbers. If n equal to 0 or n equals to 1, we have to return just n. Else, otherwise, how we have to calculate? If not 0 or 1, then we have to calculate Fibonacci series. Fibonacci number of n will be Fibonacci number of n minus 1 plus Fibonacci number of n minus 2. I am repeating, Fibonacci number of n will be Fibonacci number of n minus 1 plus Fibonacci number of n minus 2. So I will be writing the same. You have to return, by the way, as I said, like n minus 1 plus n minus 2. That's it. So it will return the corresponding Fibonacci number, whichever you ask. So let's try to do the same. So this time we have to start with 2. See, we got the Fibonacci series. Okay, great. So that's all. With recursion is pretty easy. If you still have doubts, leave a comment. I will try to address you. Okay, thank you guys. Bye bye.